to say that I had the pleasure to work with Rashid. I don't know, I don't remember how many years ago, I will not say it, but he is a very competent researcher, and for sure his seminar will be great and will give us some views of the future regarding to this interesting area. So Rashid, please.
Thank you so much, Michelle. It is a great pleasure and an honor for me to be here to contribute to this course. So today I'll be talking about the role of AI and ML in cybersecurity. So probably it's the other way around. The course is data sciences for cybersecurity, so I think it fits. Well, there were a lot of slides, but I'll take about 35 minutes, and I'll try to cover as much as I can. And I mainly talk about cybersecurity. What is the way of thinking? What are the innovations and their effect on security? What is the attacker mindset? Some sophistications in the threat, and then we will move to the machine learning and how they can contribute in this regime. And finally, we'll discuss some takeaways as well. Before I start, I'd like to thank ACM to give them the credit for supporting these lectures, ACM Distinguished Speaker Program. I would like to give the credit to ACM as well. I'll not take much time on my introduction, but currently I'm working as a associate professor and the director for Networks and Blockchain Lab. I have had some other positions as well in Netherlands, in South Korea, and some other places as well. Well, let's start with the basic definition of security. If we ask laymen, there are two point of views actually. So in academia, we treat the cybersecurity or security itself as a different from the industry. So if we ask anybody in academia, what is security? Then the terms that they would come up with would be authentication and its family and friends, which mean authorization, access control, confidentiality, integrity, privacy, availability, and the list goes on. So we also have this CIA triad, confidentiality, integrity, and availability. These are the main building blocks for security. And they provide the secure solutions for applications, for industry, and for everything. But when we move to industry, then the definition is a little bit changed. Definition per se does not change, but the perception changes. How does it change? For example, in industry, they focus mainly on those notorious attacks. They focus on risks. They focus on safety. They focus on hacking and a bigger picture, how to provide security for the entire infrastructure. Well, we can relate these things to academia, but these are more from applications perspective or the applicability. The old thinking of cybersecurity was to protect information and the content and the network. So these three parameters define the very goals of cybersecurity. So what we used to do is to isolate and protect network itself. But in 21st century, there's evolved thinking, means that, well, protecting information content and the network is okay, but these days we are thinking more about services and applications. So we have to protect these services and applications. And also, failure is inevitable in services and networks. So we have to operate through failure as well. And then it's not the service itself, standalone entity, and it's the context that counts as well. So, well, in evolved thinking, we have to think about services and applications by using the old thinking to protect information and to use the tools and techniques to protect these assets. And we have to think about failures as well because they're inevitable. We cannot have a failure-proof system or service and so forth. Okay, so the two ways, there are two 180-degree different ways to think about cybersecurity or the applicability of cybersecurity. One way is to focus more on security, and another way is to focus more on the productivity. And unfortunately, these are not orthogonal to each other, because when we talk about productivity, well, usually how it works is that you build something, you just cash out, you try your best to cash out the benefits, and then you leave it for the next generation to security, and you don't think about security. The main problem or the main challenge for cybersecurity expert would be and is currently that to convince people, to convince the administration to spend more money on security, which they're not going to. And it is fact from my own experience as well. It's extremely hard to convince people to spend more on cybersecurity. On the other hand, well, if you're focusing more on security, then what you're thinking is that you don't build something, and you don't build something until you're sure that it will be secure. So do that by design. So embed the security into the design. And where's the middle ground? Unfortunately, nobody knows where to find it. But you have to work on it with like the industry or your requirements or your applications or your services to find that very good middle ground. Well, the dilemma is that we have currently mammoth resources. We have extremely many resources, and we have that amount of data as well, which is being produced at a speed of light, I would say. And we have on top of that very sophisticated attacks, and we have the different mindsets of attackers. When we talk about cyber attacks, it is important to find an attack, but it is also extremely important to find out why does that attack happen and for what reason did it happen. And the volume of data, we could go on and on, talk about how many videos are uploaded to YouTube every minute, every day, how many tweets are uploaded to Twitter, how many comments are there in Facebook, and so forth. So the statistics are staggering, actually. If you look at 2019, like 2 years ago, there were 500 million tweets every day and 4 petabytes of data, and so forth. So in videos, in chats, in other content, in tweets, the statistics are staggering, actually. And similarly, in 2020, it's even getting more. It's skyrocketing, actually. So let's talk a little bit about mindset, attackers' mindset. Well, the first one is militaries. Of course, everybody wants cyber weapons, as we can see in today's world as well. We could have robot soldiers. The second one are government. They could be government to establish hegemony or control people. There could be corporations to have monopolies, to have competitions, or the hacker to steal information or resources for some reason, for monetary reason or some other reason. There's some other doomsday cults who want to bring the end of the world. There's psychopaths who want their name to be in the history books. There's some criminals, and people do it just because it is fun, which is another definition of fun. So in order to have the mindset, we have to look into these attacks. Now, the second important parameter is that we have to look to the innovations versus vulnerability. Well, innovation is always good. We have a very, very good connected world these days. It has been literally become the village, global village. And we can connect with anybody we want. The connectivity is so easy these days as compared to, let's say, 10 years ago or 15 years ago. And similarly, the complexity is rising as well. So if you pick up a network or if you pick up a service or an application, the complexity is also very important to consider. The networks are extremely complex these days. And on the other hand, the demands of the citizens are also growing. Well, Pick up, let's say, one application, WhatsApp, which was, for example, just used for text. Then we have file sharing in it. Then we have photo sharing in it. Then we have calls in it. Then we have group calls in it. Then we have video calls in it. And the list goes on. So the demands from citizens are also rising. And in the parallel to this, the attacks are also very sophisticated. They are becoming more sophisticated than they were before. For example, if we pick up one simple threat or attack, which is malware through malware, and the numbers are once again staggering. If we just consider 3 years ago, 2018, there were 844.35 million new malware. And then the number was going on the rise every month. And the new malware, if we just consider new malware, then every month, for example, you can see here that in November 2018, it was 8.23 million malware, but new instances or zero-day malware means that they were not found before. So that is the speed with which we have new malware. And up until March 2020, there are like 677.66 million new detections. So you can imagine the scale of these sophisticated attacks. One of the most important and my favorite one is called Mire. You might have heard of Mire DDoS botnet, which was executed by an undergraduate student in the United States, and it literally crippled the internet temporarily. Of course, it was back, I guess, in 2016, and that student, what he did is that he found the insecure things. To be more specific, the video cameras, insecure video cameras, and then use them as bot to launch DDoS attacks on OVH and DYNE, which are the DNS service provider for the internet. So it literally crippled the internet. And if it could be done by just a undergrad student for fun, it means that it's extremely dangerous if it can bring down your entire internet. And this is the map which says that where did it hit so hard back then. And it is very scary, of course. Second one is if you pick up ransomware, the ransomware itself is considered as business, I would say, in today's dark web, because they're targeting corporations, they're targeting companies, they're targeting everyone who has something to offer. This one is probably from WannaCry, and there's so many more. And if you go into the details of that, then the revenue generated by this ransomware it's huge. So that's why it's called cybersecurity economy. And ransomware attacks, if we compare these 2 years, last 2 years, 2020 and 2021, you can see that in blue we have 2020 and in green we have 2021. There's a clear difference, and it's still increasing. We are in August right now. We don't have the statistics for August, but till July, it's almost double. So you can imagine the speed with which we are having these ransomware attacks. Okay, so that was all about setting up the stage for the technologies and for the sophistication of cyber attacks. Now let's focus on the artificial intelligence and machine learning. Well, you all know that machine learning is nothing but capability of learning without explicitly being programmed. And then artificial intelligence is the superset, which means that the capability of imitating some very intelligent human behavior. So the learning part is done by the machine learning algorithm or model, and then artificial intelligence adds on to the perception, decision, and all the way to autonomy. If we take it further, then there are two ways to think about programming. One is traditional programming, where you have a program and you have data, and then you run this program and you have an output. But machine learning is the other way around, where you have data, you have output, and at the output side, you have the program, which means the outcome. And there's the types of learning. This figure is from my previous paper. We used it for cybersecurity through machine learning in Internet of Things. You can see that we have supervised, unsupervised, semi-supervised, and reinforcement learning, and they are used for very different functions in, let's say, Internet of Things applications. For example, popularity prediction, weather forecasting, market forecasting, diagnostic, customer segmentation, and so forth. So based on the application, you can pick up any of the existing machine learning tool to use it against. Okay, in the forms of AI, we have, for example, applied AI. Means that if there's a specific task, this applied AI can deliver very exceptional performance. We will see that why we are discussing these things, because we will converge it to the IoT and the features. So if we consider malware detection, it is very specific task. And object recognition, for example, or Apple Siri that we are currently using. And they actually, so this applied AI, it uses very well-known machine learning techniques. For example, we could use deep learning, we could use natural language processing, we could use neural networks, and so forth. And the second form is what we call it artificial general intelligence. It means that it's a notch higher, where the intelligence or cognition task, they're as good as human, or at least they learn how to do different things. So this is what we call artificial general intelligence. And the third one is called strong AI. It is almost as applied AI, but with consciousness and self-awareness. So we currently, if we consider the current status, we are far away from the applied and general AI and strong AI, of course. But there are like efforts being made by Google, by IBM, and some other big shots to be as near to it as possible. So if we take an example, then an object detection itself could be performed by machine learning, and the operation of an autonomous car can be considered as the goal or the function of artificial intelligence. Now, why exactly learning is important in these cases, for example, IoT? Because the complexity in data is huge. If we pick up, for example, smart home data, or you pick up data from industrial IoT system, or you pick up data from, let's say, healthcare applications, body area networks, and so forth, then there's, of course, complexity in data. And the human intuition is extremely hard in these cases. If you have a log file which is a gigabyte large in size, as a human being, you wouldn't be able to look at that log file and make sense out of it. And on top of that, there's scarcity of resources, and the changing pace of cybercrimes and the speed, velocity, and veracity of these cybercrimes is also very important to think, because they also add to the necessity for learning. Or if we say it another way, it would be to automate it. So if we want to use machine learning in cybersecurity, it means that what we are trying to do is to develop some computer programs which have the ability to identify and block new kind of attacks or threats. Okay, so that is the main goal for using machine learning on security. But once again, here, what we are trying to do is to focus on automation. It means that we have logs from the networks or from applications, and we want to train our machine learning models on those logs and see what are the patterns, what are the anomalies, and if there's something wrong with the setup. If we take an IoT as a use case, as I said, there are numerous applications and domains. That could be healthcare, that could be business, that could be production, that could be smart home, smart infrastructure, and so forth. So the terms that we define, for example, data complexity and so forth, all are applicable equally in IoT as well. So how does this learning help? Here I have highlighted the keywords. First one is prediction. Second one is prior solutions. So you have to look into prior solutions, means that you have to learn something from them. And then the solution has to have the ability to use some, for example, NLP techniques to analyze some unstructured data. And then to have unique solutions and some detailed insights to either detect or stop or prevent the threats. So that is the main idea behind using machine learning techniques. We could have predictive analytics, for example, which are used to detect, for example, anomalies in the network patterns, who logs in, what time logs in, what resources are accessed, and so forth. And for being able to identify some intrusions without having a prior signature. Because usually if you have prior signatures, then it is rule-based, but most of the time you don't have prior signatures. So what do? You focus on behavior. So behavior analytics, they also help. And the beauty that machine learning and artificial intelligence bring is that they use the gut feeling or their ability to predict something that might be an attack. Okay, this is good, but the network size is really monster because once again, the example of log file, a simple human being cannot simply just go through the log file of a gigabyte and so forth. And the advanced persistent threats or other shocking mechanisms that should be considered when we do the predictive analytics. I'm sure you might know about Stuxnet. Stuxnet is one living example of advanced persistent threat. No matter what you have as a defensive mechanism, you have Stuxnet, which is intelligent enough to evade all the security mechanism that you want. So you have to think from that perspective as well. URL. So what you have to do through machine learning techniques is to understand, to reason something about it, and then learn from those reasoning. So to boil down, the role of machine learning is these three: understand, reason, and learn. Okay, all this is, once again, it is good, but the worst nightmare in cybersecurity or for cybersecurity expert is the false positive. Whenever we talk about behavior, if we're not 100% sure, then we have something which is false positive, and it wastes much of our time, and the money sink into this particular parameters as well. And we don't know what exactly normal behavior is, because normal behavior for one application or one domain is very different from normal behavior in another application or another domain. So you have to have a local definition for this normal behavior. So that is also extremely important to think. How AI is trying to reduce the false positive to take context into account. Well, it cannot completely finish it, but if we take the context into account, it means that we can reduce these kind of false positive. This was all about the traditional machine learning techniques, but we also have adversarial machine learning for the last decade or so. Well, good guys can use machine learning to stop the attackers from attacking our system. But what the attackers, the attackers cannot be stopped from using the same machine learning techniques against the good guys through adversarial machine learning. So how that is done, to learn some approximate machine learning model, and then through interaction with that model, craft some inputs, for example, or perturbations that could result in the failing of that mechanism. Okay, As an example, if we talk about perturbations, image perturbation, then this is from a paper which was published a couple of years ago, not couple, but I think few years ago. So if there's an input banana, then the normal classifier would classify it as banana with almost 99% probability. But with a crafted input, if we have that input, then this could be, well, misclassified and classified as toaster with 99% probability. Well, this is shocking, right? So we need to have the security of machine learning itself. Of course, we want to use machine learning for cybersecurity, but what about the security of machine learning itself? This is from 2014, from the good Ian, the founder of GANs, good fellow. Well, once again, it is about perturbation. So with 57.7% confidence, this is Panda here, but here you can see that 99.3% confidence it's given, with certain noise added to this picture. So it means that this could be very much done. I don't have the slide for that, but I've been working with my students as well. We were trying to find if we could fail the federated learning technique and attack it by perturbation, and we were easily able to do that in our own research. Behavioral attacks are same. I would not go into the detail of that, but generative adversarial networks have brought revolution in the field of AI, as you all might know. Well, where we have two neural networks, one is generator, the other one is discriminator, and it has numerous applications everywhere, and the same stands true for cybersecurity as well. Well, if these two models are competing against each other and try to fool each other, they become even stronger. So if we think from the better perspective, we can do that for behavior analytics and so forth. But the same thing could be done by attackers as well. And again, as an example, in federated learning attacks, we use these generative adversarial networks to give us the new inputs that we could input to the machine learning model and to try to fail it. So that is also very much possible. Okay, so the future of cybersecurity, well, despite all these concerns that I talked about, adversarial learning and using machine learning for attacks as well, well, the advanced AI and machine learning techniques are inevitable. We have to use that. The reason I already told you. So there's no silver bullet that would save us from all these attacks. But at least AI and ML and DL, they're going at least closer to that. So if we combine them with the context of services or applications, then what we can do is that we can bring down the speed of attacks at least a little bit. So what exactly can we use these AI and ML for if we talk about cybersecurity? Mainly their intrusion detection systems, authentication, authorization, access control, against DDoS, against malware, against eavesdropping, jamming, and so forth. So the literature is full of these, and the same is true for all the applications, including Internet of Things as well. Well, I'll just touch upon the final point in this talk. That we try to talk about the advantages of machine learning, how it can help to focus on the cybersecurity, to improve cybersecurity, and so forth. And all these things are brilliant. They're very good. But the problem is that, do we for sure know how this AI work? So we have to be sure that the artificial intelligence techniques or models, they're transparent enough to the user, to the developer, that their working principles are known. But the problem is that if we talk about neural networks, multi-layer neural networks, multi-layers neural networks, then it is extremely difficult to know how they work. Why do we care for that? if we are doing some mission critical applications, for example, in health, robotic surgery, nuclear power plant based some services, for example, some critical infrastructure, then we really need to know, we have to be 100% sure how this AI mechanism works. Because if we don't know, then the outcome might be something different than what we expect. So that is why we need to know how AI works. Usually, AI is referred to be a black box machine, but we need to make it white box. So recently, a new area emerged, which is called explainable AI. Or interpretable AI. What exactly this explainable AI is? It is a set of tools and frameworks that help to develop interpretable and inclusive machine learning models. Okay, so the same machine learning model, but it should be inclusive and should be interpretable. If tomorrow you want to know the decision that was taken by artificial intelligence, you want to know how this decision was taken, which parameters led to take this decision through artificial intelligence or machine learning model, and so forth. Imagine a transplant surgery by a robot. So we have to know the outcome of these artificial intelligence tool or models to take that decision into account. Or if there's an autonomous car that is speeding at 120 kilometers per hour on a highway, you need to know if there's an outcome of from the artificial intelligence model, be it an object detection, be it a perception, be it actuation, and so forth. Okay, so there are different stakeholders in AI. I'm trying to wind it up here, but it is extremely important to focus on the explainability of artificial intelligence as well. And it is equally important in cybersecurity. In addition to explainability, fairness is also extremely important, because most of the time, if you're using machine learning for cybersecurity, then you're dealing with lots of data. If you have lots of data, then the data representation is extremely important. You have to be sure that there's a fairness in representation of that data. If you take an example, here, if there was a task where everybody was asked to, let's say, draw a shoe, okay, and then a machine learning model was used to predict or to classify that shoe that was drawn. So, well, most of the people, since the participant, most of them were male, so what they did is that they focused on the shoe that is usually worn by men. But the input, for example, if it is this input to this machine learning model, it failed on it. It doesn't mean that there's something wrong with machine learning model, but the data itself was incomplete and it was not fair. So the representation was not fair. That is why fairness representation is extremely important. But the other side of the story is that now there's a discussion whether we really need this explanation. Okay, at NeurIPS conference a couple of years ago, there was a challenge or a survey, I would say, that there's a critical surgery which is done by a robot, and you have a 3% chance of dying, but you cannot ask any question from this robot. On the other hand, well, the same surgery is done by a human doctor. Okay, but the percentage of dying or probability of dying is 15%, but you can ask any question from that doctor and the doctor will explain everything to you. Now, the real question is whether would you prefer a robotic surgery or whether you would prefer a human doctor surgery. Like, which one would you choose? Would you trust your life with a robot, or you would trust the explanation by a doctor? That is another myth that is currently considered by so many people and in the research community as well. So the takeaways from today's lecture are that there are lots of opportunities, and machine learning, deep learning, artificial intelligence are really evolving. There are lots of challenges, and the stakes are extremely high as we go vertically and both horizontally and vertically through these applications, domains, and so forth. We don't have to reinvent the wheel, of course. but we have to make the existing wheel more efficient. And AI and machine learning, it really benefits us, but it benefits actually attackers as well. We have to use the expertise from both cybersecurity and from machine learning or artificial intelligence as well. As I said, this AI or machine learning is not a silver bullet. It will not solve all the problems. And at the end of the day, human intelligence will prevail. But we have to focus on, in the current era at least, we have to focus on the explainability of artificial intelligence. That would be all from my side. Thank you so much for your attention. If there are any questions, uh, I would take the questions now.
Thank you so much, Harshid. It was very, very good. I mean, this is also what you presented goes also in the direction that we had as inside our course at UFMG. We had a lot of discussions regarding to many topics that you have raised. I will open for questions. So please, we have three questions, in fact, on the chat. You have also the comments there.
Okay.
So one of the questions is from Leandro Souza. So he asks, or he says, considering the rise of the cyber attack economy and the resulting increase in attack instance, do you believe there is enough training of cybersecurity professionals in order to counter this?
This is actually extremely important question. In my own experience, as I'm working with industry as well, well, in academia, I would reply to this. I would respond to this question in two ways. From academia, of course, we are trying to provide awareness, but most of the time we don't have those resources to put students through the real test bed or real environment. The training of cybersecurity professional is extremely important. Having knowledge is one thing, but having training is another thing. At academia, we can contribute to the knowledge of the expert and the students, of course, but we really need the collaboration with industry as well. Currently, in our master program, which I'm running, Security and Network Engineering, there are companies, for example, Group IB, which is one of the largest forensic company here, Acronis, and some other companies. We are trying to invite them to offer courses here, hands-on courses. So I think it's extremely important to have the real-world experience as well. So yes, it is very important.
Another question he raised here is, are there real world examples of efforts in this context that can serve as an example for us here in Brazil?
Okay, so if I give an example from the experience that I have, is that I would mention this company again. So what they did is that they share their experience with us and the real world experience. Like the ransomware going on. There, of course, there are so many ransomware, and those people are incident response team. So of course, due to NDA and those kind of things, we cannot share every bit of data with us, but they share their information with us. And I think probably as a company, they are not going to spend too much effort on the artificial intelligence side. But if you have the data from a couple of years or 5 years or 10 years and so forth, and you're trying to find the patterns, it will be extremely good to predict something that is going to happen in the future. So in the real world, I think there are companies, especially the ones that I'm aware of, Of course, Google, Facebook, and some others are trying very hard to do these things. But now I think the pace is changing and everybody is going towards machine learning because there's no other way. With the volume of information and the scarcity, there's no way that statistics or other techniques could help you. So you have to come towards learning.
And also, if the company doesn't use it, the attackers will use. So
exactly,
you will be in a very negative position regarding to
exactly,
that. Yeah,
exactly.
There is another question from Tariq Alvis. He says there are some models and tools that make machine learning explainable, like Lime. But I wonder if these tools can themselves become vulnerabilities. What do you think?
Very much possible. And this is one of the area that has not been explored yet. As I said, there's a buzzword always. Now everybody is running towards, if we take the example of blockchain and Bitcoin, everybody was running towards blockchain and still, even if it is not needed, people are using it. Same is going on with explainability. The goal is clear for explainability and explainable AI, but nobody has yet looked into the dark side of it. One good thing that is happening is that I can share with you is that usually what people are trying to do is that machine learning model we already have. So we already have deep learning, we already have artificial neural networks, and so forth. So what people are trying to do is to have a parallel mechanism that is going to bring post hoc explanations. Post hoc explanation means that you have the result and everything is done, and then it is creating an explanation for you. How did it reach to that point? Yes, it is vulnerable and it could be vulnerable, and it needs, I think, more research. And this is one of the very active research topics actually these days to find the vulnerabilities in explainability itself.
And it's very hard. I mean, you showed here XAI. I didn't know about it. I really like it. You raised that. But I think that this explainability point is one of the most important point regarding to using machine learning
Yeah,
and validating the models. Everything is.
and there's another, Michelle, there's another reason behind it. For example, there's autonomous car. It has an accident. Now you're trying to find out so the insurance company wants to find out who is culprit. Was it the machine learning model? Was it the data set? Was it the programmer? Was it the owner? Was it the operator? Who was? So you need to know how this decision was taken to bump into the tree or to stop or to do what. So that is why it's also very important for so many stakeholders actually.
This also brings us to the next question from Daniela. She says, how do you think we could move from explainability to causability
Good.
in ML?
Yeah. Well, as a matter of fact, causability, or in other words, causality, is used as one of the techniques in explainability. So far, according to my information, I'm following the autonomous car models in my own research as well, and I'm following the explainability in that. So what they're trying to do is to have the causality, means to see the context in which, if, for example, if there's a zebra cross sign, then having a break is imminent. It's necessary. So you take those kind of things into account to explain the decision that is taken by the object, or by the machine learning model. Some of them are very trivial, but others are extremely complex. So causality is used one of the means to do these explanations.
Very good. Now we change a little bit the subject. This is a question from Ali Baladur. He says, thanks, and how important is data set generation in IDS performance? And is there any research on collecting or generating relevant and fair data sets?
This is Ali. This is once again a very important question. I
Hello?
would share my experience with you from Royal Bank of Canada, with whom I was working. We were working on API security and intrusion from that end. We had millions of data points, but the fairness itself, as we looked at it, it was not possible for us to look at whether it is fair or not. But once again, it comes back to the application of where you're using it. So what we call is when there's fairness, we call it a sensitive attribute. So sensitive attribute in some applications, for example, for example, crime rate. So there's a practical example from United States Police. They were using artificial intelligence, and somehow the colored people were predicted more risk as compared to the non-colored people. So that is a bias in data, of course. So the data set generation, if we come back to the IDS, yes, it is extremely important. And I personally don't know if there's any group working in this direction, but I have personally worked with a large data set myself. But that was, of course, the data was masked before coming to me because that was customer data. You have to look into application. For example, if there's a crime rate, it means that the race is very important and sensitive attribute. If there's a loan, then once again, gender and the income, these are the sensitive attribute. If there's any other application, then you have to first identify the sensitive attribute or sensitive parameters in that data set. Then you can say whether it is fair or not.
We have another question regarding to, this is from Carlos Pedroso. He says in dynamic and low power networks such as IoT that use real time data, how to use machine learning?
It is yes, a very interesting question. The research community is using something called distributed learning. You might have heard of it, distributed learning and federated learning. And or another term used for this is learning at the edge. So what you try to do is to bring the learning as closer to the thing or the object of the Internet of Things as possible. With phones, for example, with the handheld phones, it is not big of a problem, but with the sensors, of course, it's a problem. So what is being done is that we bring the learning to the edge, and we have certain mechanism where the data is shared from the things with the learning entity, so to speak, and then they produce these results. But the problem is that we can lose the privacy in that matter. So in order to increase privacy, the learning model itself, very tiny and very lightweight learning models are used by the end users, or we call them workers, and they just send the parameters, hyperparameters, or the learned mechanism to the collector. So both ways are okay, depending on how much resources do you have in the network.
Very good. Now we go for the last question that we have here, is from Pedro Henrique. So he asks, how do you see the future projection of approach involving federated learning for cybersecurity systems?
Yeah. It is actually one of my students was working on it. What we are trying, I'll share the idea with you. What we are trying to do is, okay, in federated learning, you know that there are workers. The same machine learning model is shared with everyone. They have their local data. They train on it and send the result back to the
Cloud?
the collector, or yes, the root node or whoever that global node is. What we are trying to do is to, okay, if you're trying to corrupt one of these with perturbation or any other techniques, then well, it will be a disaster for the global model because that will not converge in time. Even if the attack is not attacking, it's not a real attack, but it will slow down the convergence. So what we were trying to do is, okay, what if we randomly pick at each iteration, we randomly pick a subset of these workers, let's say, okay, and this brings us to two things. First, how the convergence time will be affected. Second one, how the accuracy of the classification or of the prediction or these kind of things uh, will be affected. And third one is that, okay, if we have enough workers that are being compromised or they have fooled the machine learning model, what will be the effect on the on the global model. So currently, this is a very active research area. People are working on it, and these are the questions that are being searched and that are being answered by the research community. So one thing I would share that, well, mainly federated learning is used for privacy preservation, and what people are trying to do is to see if there's some leaked information in those parameters. So it is also possible that you might not have 100% privacy as a result of running this federated learning model, but there could be some leaked information into those hyperparameters. So this is also another way to look at it. As a whole, I think it is very interesting area and people are actively working on it, federated learning. Yes.
Hashid, thank you so much. We
Thanks
were
to
talking
you.
about we were talking about in the beginning before going live about collaborations. I will be very glad to collaborate with your team, and of course from our side, my team as well. I'm sure they are very open to this kind of collaborations. For the people in the audience, we have master and PhD positions open. So if you are interested to work on these topics that we have discussed here, and maybe collaborate with Harshit also, so we can talk regarding to this point too. So again, Harshit, thank you so much.
Thank you so
And
much, Michelle.
your
It was
time
really
was
pleasure.
great. Yeah.
Well, thank you so much. I'm looking forward to collaborate with you again, of course.
And again, for everybody, I would like to highlight that Hashid is an ACM distinguished lecturer. This is a very prestigious position, let's say, to disseminate the area of cybersecurity around the world. I'm very glad that you had the time to share a little bit your research with us here in
Well,
Brazil.
thank you so much. It's a pleasure. It's really a pleasure. Thank you.
Thank you. Thank you,
Thank
everybody.
you. Thank you. Have a good day.
You too.